In this video, I'm going to talk more about standard deviation, and we're going to learn a new rule that will help us to find out more information about data that is normally distributed. In this example, we're talking about the ACT scores from 2010. The mean score was 21 and the standard deviation was 5.2. We also know that the data was normally distributed. We're going to use this information to answer some questions. I've already drawn for you the shape of a normal distribution. If you're told that something is normally distributed, then it must look like this bell curve that is unimodal and symmetric. Now, you should feel comfortable drawing this on your own in the future, but for now, we already have it drawn for you. We need to label where each score belongs on the curve of the data. So the first piece of information we were given is that the mean was 21. We know that in a normal distribution, the mean is always exactly in the center of the data. So we can label this center tick mark with the mean of 21. Now, the other piece of information we're given is that the standard deviation was 5.2. On the line below my curve, I've labeled tick marks that are evenly spaced. The space between each of these tick marks represents one standard deviation. If you forgot, standard deviation is a measure of how spread out the data points are on average from the mean. So on our curve, each tick mark represents one standard deviation away from the mean. So for example, if I look at the tick mark that is to the right of 21, that tick mark is one standard deviation above the mean. And I'm going to use the letters SD to abbreviate standard deviation. Since we were told that the standard deviation was 5.2, I can just add 5.2 to 21, and that will give me the score that is one standard deviation to the right of 21. So that would be 26.2. So I'm going to label that tick mark as 26.2. So whenever you know that something is normally distributed, you want to take the time to label all of these parts of the curve before you start answering the questions. Now, if we go one more standard deviation to the right, that means I'm now two standard deviations above the mean. So I'm going to take 26.2 and add the standard deviation again. So I'm going to add 5.2. Now I'm two standard deviations above the mean, so I'm at 31.4. And I can do this one more time to end up three standard deviations above the mean. So I'm going to add 5.2 one more time to 31.4. And that gives me 36.6. Now, of course, there can be scores above 36.6. As you can see, there is still a little bit of a tail there, but we'll talk more later about how few scores are above that third standard deviation. Now we can do the same thing to the left of the mean, except we're going to subtract. So we want to find what score is one standard deviation below the mean. So instead of adding, now we're going to subtract the standard deviation. So I'm starting with my mean and I'm subtracting one standard deviation. So 21 minus 5.2 gives me a score of 15.8. That is one standard deviation below the mean. I'll do it one more time to get two standard deviations below the mean. So I'll take 15.8, subtract 5.2 again. That gives me 10.6 as the score that is two standard deviations below the mean. And now one more time to get three standard deviations below, I'm going to subtract 5.2 again, minus 5.2. That gives me 5.4. So as you can see, you end up with a very low score all the way on the left, and you can tell that not many people are getting the scores that are farthest to the left or farthest to the right. Or in other words, the ones that are three standard deviations away. So now let's answer the first three questions, because these are all about what scores are different standard deviations away from the mean. So the first question says, which ACT scores are one standard deviation away from the mean? Well, we have 15.8, that's one standard deviation below the mean, and we have 26.2, which is one standard deviation above the mean. So those are the two scores that are one standard deviation away. Which ACT scores are two standard deviations away from the mean? Well, if you go two tick marks to the left of 21, we get 10.6 being two standard deviations below the mean. And if you go two tick marks to the right of 21, you get 31.4 being two standard deviations above the mean. Which ACT scores are three standard deviations away from the mean? Same thing, if you go 3 tick marks to the left of 21, you get 5.4 is 3 standard deviations below the mean. And if you go 3 tick marks to the right of 21, you get 36.6 is 3 standard deviations above the mean. The next question asks, what percentage of students scored between 15.8 and 26.2? Now you might be wondering, how can we figure out a percentage of students? All we know right now is what scores are different standard deviations away from the mean. Well, this is where the 68, 95, 99.7 rule comes in, which this is a rule that you just have to remember what percentages of people are in which parts of the curve. So the 68 is telling us that there are 68% of people within 1 standard deviation of the mean. So what that means is the total percentage of people that are from 15.8 to 26.2 for their ACT score is 68%. So we just know that that part of the curve represents 68% of the people. 95 is telling us the percentage of people that are within 2 standard deviations of the mean. So 95% of people have an ACT score that is between 10.6 and 31.4. So that's including the people from before. We're just getting bigger pieces of the curve. Now the 99.7 is telling us the percentage of people that have data within 3 standard deviations of the mean. So in this case, it's telling us that 99.7% of students scored between 5.4 and 36.6. So as you can see, 99.7 is very, very close to 100, but not quite. That's because we still have those little sections of the left and the right, the small part of the curve. And if we included everything under the curve, that would give us 100%. So it's important to remember that the curve does overall, if you add up all the percentages, should give us 100%. But right now we're just talking about how many people are within each standard deviation. So the question asked us what percentage of students scored between 15.8 and 26.2. Now this is just a quick application of our rule. We can see that 15.8 and 26.2 are both 1 standard deviation away from the mean. So 68% of people or of students scored between these 2 scores. The next question asks what percentage of students scored below 10.6. Now that means we're trying to figure out, if we look at 10.6, we're trying to figure out the percentage of students that scored below 10.6. So we're trying to find the percentage of this yellow shaded in area. So we're going to have to do a little more work for this because right now we only know the percentages of each of the chunks that I outlined. And keep in mind that this rule applies to all normal distributions. So anytime you have something that's normally distributed, you can apply the same exact values of percentages to whatever you see on the curve. So of course, in this case, we're talking about ACT scores. So that's why we have the specific mean of 21 and the standard deviation of 5.2. Those things will definitely change depending on your scenario, but the 68, 95, 99.7 rule and those percentages will always stay the same. So I'm going to show you something else that you can apply to every normal distribution you look at. And I'm going to show you how I get this using the rule. So if I'm trying to figure out the percentage in this area, it would be helpful to know the percentages in like each chunk of the curve. So I'm going to start in the middle again. I know that 68% of the scores are within 1 standard deviation. So I can figure out how much percentage is in each of these 2 chunks by dividing 68 by 2. If that whole section is 68% and I want to know what amount each half is, I just divide 68% by 2. So that means that each of these sections is 34% of the students. I can do the same thing moving outwards in my next 2 sections. And you can tell these are going to be smaller percentages than 34%. So for this, I need to figure out what percentage is left over in the 95% section because we're looking 2 standard deviations away. So we're looking at that 95% chunk, but I've already accounted for 68% of it. So I'm going to take 95 because that's the percentage within 2 standard deviations and subtract the percentage I already accounted for, which is 68. So that tells me that 27% of scores are in these 2 sections that I just outlined. But since there's 2 sections and I want to figure out how much is in each section, I'm going to divide 27 by 2, and that gives me 13.5% in each of these sections. Now I'm going to do the same thing again for 3 standard deviations away. I know that overall, this big section from the 3rd standard deviation below to the 3rd standard deviation above is 99.7%, but I've already accounted for 95%. So I'm going to subtract 99.7 minus 95, which gives me a leftover of 4.7% in the next 2 outer sections. But since there's 2 sections, I'm going to divide this by 2, and that tells me that each of these sections is 2.35%. Now don't forget, we still have these really tiny sections on the very far ends. And since we know that all of the percentages should add to 100, we're going to take 100 and subtract the amount we already accounted for, which is 99.7, and then split it into the 2 sections. So that tells me that these very small sections are representing 0.15% of students, which is very, very small amount of students. And if you were to add up all of these percentages right now, it should give us 100. So let me just show you really quickly. So if I add up all of the percentages in each chunk, it's going to give us 100. And it does. So now that I've showed you that, you actually don't have to do that math all over again. Anytime you have a normal distribution, you will know that each of these sections is worth these percentage of the people in whatever situation you're looking at. So you can always use these percentages when you have a normal distribution. So now that I figured this out, I can figure out the percentage of students in this yellow section that scored below a 10.6. I just need to add up the percentages in each part of the shaded area, which is 0.15 plus 2.35, and that gives me 2.5% of students scoring below a 10.6. So remember, all of the percentages that we found, you can apply to any normal distribution.